Alright, so I'm going to show you how to solve kinematic equations. I'm going to do this for my very poorly written problem here. However, you could get this information from measurements you've taken, oh, I don't know, a graph, something like that. Okay, so let's start off with first writing out your three kinematic equations. If you have not taken notes on where the kinematic equations come from, you need to do that, those two videos. Anyway, so let me go ahead and show you how to do this. First of all, I'm going to start off by writing the three kinematic equations. Very soon I will show you a trick for this. The first one, final velocity equals initial velocity plus acceleration, sorry this pen's weird to write with, times time. Okay, the second one, final position equals initial position plus velocity initial times time plus 1/2 acceleration times time squared. That's the skull one. Okay, and then finally, this is the one that I did the flipogram thing of with the black background. Velocity final squared equals velocity initial squared plus 2a acceleration times s displacement. Guess I forgot my vector arrows up here. It's not that huge a deal. If you did one of them, you know, probably should do all of them. Anyway, I didn't leave them out for any kind of reason. Alright, so those are your kinematic equations. Notice this one right here. First one is missing. They all have initial velocity and acceleration. This one is missing displacement. This one right here, because look, you can bring this, subtract final position, or initial position on both sides, and that'll give you displacement. This one's missing your final velocity, and this last one is missing time. We haven't talked about the last one as much. Alright, so there are 5 things that you can, 5 different variables if you look at all of these. You have your acceleration, and actually this order that I'm putting these in is pretty useful. Acceleration, time, so it spells add it first, velocity initial, velocity final, okay, and displacement, which if you need to, you can break down to final and initial position. Put the arrows. Okay, so if you have 3 of the 5 of these, you can use one of these up here. Well, let's get a sense of what's going on here. You should always look at the picture. So you got a car, starts from rest. It's my car. It does not have to be pretty. It does not want to let me draw wheels. Car. Velocity initial equals, well, it's from rest, so 0. Okay, then it's gonna accelerate. I guess I should make this the positive direction and this the negative direction, although that would make sense. 8 meters per second squared. Notice I didn't write positive down here because I have the arrow. And then it's going to end up with a velocity final over here, which you don't know what that is. Don't think we really care. And we want to find out this, how far it traveled. Displacement. Question mark, and I'm going to put a star by that because we want to solve for that. Oh yeah, and you know that the time is equal to 4 seconds. All this transpired in 4 seconds. So I've got my really ugly little picture that works more than fine. Okay, so now I'm going to go in, let me switch colors. Not that that's that huge of a deal. Okay, anyway, and this works for all problems that you can do kinematics with. It even works in 2 dimensions, you will see soon. First, do I know my acceleration? Well, yes, I do. It is 8, and I might write the positive here because I don't have that arrow. Positive 8, if it's going to let me, meters per second squared. Time, yes, I know that. It is 4 seconds. Velocity initial, I start from rest. It is 0. Okay, velocity final, I don't know. And I don't have that information at all. We'll come back to why that's important. And displacement, I don't know. And I care very much. That's what I'm looking for, is how far it went. Okay, so let's look at this. Remember up here, this one is missing displacement. That's what it's missing. This one is missing final velocity. Remember, they all have initial velocity and acceleration, and then this last one is missing time. Well, what you're going to do is look at this thing that you're missing, and this isn't the case all the time. Sometimes you have 4 things and you're good. You can use several of them. So you've got this right here, your final velocity, right? That you don't have, you have no way of knowing, no one asked you. And guess what? If you come up here and find the equation that's missing final velocity, that will work. So yay, it's this one, the skull one, that you're very familiar with. Okay, so let's write that out. That's supposed to be next, final equals, or final position minus initial position, those are x's, plus initial velocity times time plus, ooh, sorry about that. Let's see if I can do this a little bit better. Plus 1/2 acceleration time squared. Yeah, that's better. That little pen thing I have is not working. So I'll make this a little bit better. Final, that's velocity initial times time. It's up there. You should know this. Okay, so I'm going to subtract the initial. You always want to solve it for whichever variable first. So I'm getting rid of my initial. So this gives you, look, change in x, which is also displacement. I'll just do this really quickly so I don't have to change my x. Change in your x position, your horizontal position. Right? Because it's like you went from initial right there to final right here. So that gives you change in position. Right? So that will equal, oh wait, and hey look, this initial velocity is 0. Love it when that happens. That whole middle term, that's supposed to be like a Ghostbusters no smoking sign. Okay, so your final position equals 1/2 acceleration time squared. Now if you do something like this on a spreadsheet, I will ask to see your work. Okay, so let's plug this in. So that's going to equal, oh, we have all this information. This is awesome. So I have 1/2, and I really probably would never really do this kind of much math. I would probably plug this into a spreadsheet completely. So that would be 8 meters over second squared, because see the 8's gonna be the numerator. Okay, and then look at this time squared. It will go out here, so we're going to square 4. We're going to square 4, which 4 times 4 is 16, and we're also going to square the seconds, which seconds times seconds is seconds. Okay, cancels out, cancels out. So look at this. This is why I like to do this way. I'm not going to multiply 8 times 16 and divide by 2. Forget that. I'm just going to change the 16 to an 8. 8 times 8 is 64. Let's check the units. Meters, because you know the second squared canceled out. Meters. There you go. That works.